Okay, so we're stepping it up a little bit today, and we're going to solve two-step equations. So one-step equation meant that there was one operation in the problem. Two-step equations involve two operations. So you're going to see a combination of an adding and subtracting and a multiplying or dividing. Okay, it's not going to be all four, but it's going to be two of them. One from adding and subtracting, one from multiplying and dividing. There is a certain order as we're solving these. So just like you learned PEMDAS in 7th grade and 6th grade, when we're solving equations, we're going to do the opposite actually. We're going to follow SADMEP, which I know sounds silly, but there it is. So the idea is we work our way backwards from PEMDAS. Instead of PEMDAS, it's SADMEP. So we take care of any addition, subtraction first. Then we take care of multiplying and dividing. Now we're not going to see in 8th grade exponents or parentheses, so it's really just SADM if you think about it, okay? So let's look at number 1. So I want to get x by itself. Well, I see multiplying by 6 and I see adding 8. Well, according to SADMEP, I need to take care of addition first. So the inverse of adding 8 is to subtract 8 to both sides. So I have 6x, where these 8's cancel, equals 50 minus 8, which is 42. Now I'm left with multiplication. So that's my next step, dividing or multiplying. So since I'm multiplying by 6x, then I do the inverse, which means I'm going to divide by 6 to both sides. So these 6's cancel, and I have x equals 42 divided by 6 is 8. That's wrong. That's 7. I can do math. There we go. Okay, so let's do some more practice problems. So if I look at number 2, I see multiplication and I see subtraction. Well, according to SADMEP, I've got to take care of that subtraction first. So the inverse of subtracting 5 is to add 5. And so I have 2x, where these 5's cancel. 11 plus 5 is 16. And now I'm left with a multiplication problem. And the inverse of multiplying is to divide by 2 on both sides. So I have these 2's cancel, where I have x equals 16 divided by 2 is 8. So more practice problems. Look at number 3. So I see multiplication and I see addition. So according to SADMEP, I'm going to do subtraction and addition first. So the inverse of adding is to subtract 9 to both sides. So I have 13 minus 9 is 4, equals negative 4x, where these 9's cancel. Now I have multiplication, and the inverse of multiplying is to divide. I'm going to divide by negative 4 to both sides so that I have nothing left next to x. And 4 divided by negative 4 is negative 1. Number 4 is tricky because of the setup. So what makes this tricky is I see multiplication, and then it looks like I see subtraction. Well, either way, I need to take care of subtracting and adding first. How I do that is I need to move the constant over, the 7. So the opposite of a positive 7, like to get rid of that 7, is I'm going to subtract by 7. But then I know what you're thinking. You're like, Miss, but I see subtraction. Why aren't I adding 7? Well, if I add 7, think about it. 7 plus 7 is 14. I haven't gotten rid of it. So I have to subtract 7 to get 0 there. So I'll do 7 minus 7, that cancels. So I have negative 3x equals 34 minus 7, because I subtracted, is 27. Now I see multiplication, so I can take care of that by dividing by negative 3 to both sides. So these negative 3's cancel to get x by itself, and 27 divided by negative 3 is negative 9. Number 5, so I see division and I see subtraction. Well, according to SADMEP, I've got to take care of the subtraction first. So I'm going to add 7 to both sides. So I have x over 2 equals, these 7's cancel, 9 plus 7 is 16. Then the inverse of dividing is to multiply by 2. So these 2's cancel, where x equals 16 times 2 is 32. Number 6, I see division and I see addition. So I have to take care of subtraction and adding first. So I'm going to, the inverse of adding 8 is to subtract 8. So I have 11 minus 8 is 3, equals x over negative 5, where these 8's canceled. Now I see division. The inverse of dividing is to multiply by -5 to both sides, where these -5's cancel and x equals -5 times 3 is -15. Number 7 is a lot like number 4, where yes, I see subtraction, but I'm actually not going to be adding. Since I want to move the 9 over, yes, I see the subtraction, but the 9 is positive. So if I try to add 9, then it's not going to cancel the 9s, which is what I want to try to do. So I'm actually going to do the opposite of a positive and subtract 9 from it. So I have these 9s cancel, and I have -2x equals 35 minus 9 is 26. Then I can take care of the multiplication, so I'm going to divide by -2. So x equals 26 divided by -2 is -13. Number 8 is a lot like number 7 as well, just on the other side of the equal sign. So yes, I see subtraction, but if I try to add 15, it's not going to cancel. So I actually do want to subtract 15 so that these end up being 0. And 78 minus 15 is 63 equals -7x. So then I can divide by -7. Those cancel, so I have x equals 63 divided by -7 is -9. Last one of these, again like number 8, number 9 similar. So instead of adding 22, I'm going to subtract 22. So I have -2 minus 22 is -24 equals, these cancel, so -2x. Then I'm going to divide by -2. So -24 divided by -2 is +12 equals x, because those 2's cancel. Now, we've been practicing SADMAP for these first 9, but there are special cases and exceptions to SADMAP, and that is when you have problems like these 3. So if you look at like number 10, I see addition and I see division. And according to SADMAP, I technically take care of addition first. But what's happening here is I'm dividing the entire thing by 8. So the dividing by 8 kind of takes over the adding part. So I'm not going to do SADMAP, I'm going to do the reverse. So I'm going to take care of the division first. So the opposite of the inverse of dividing by 8 is to multiply by 8. And as soon as I've done that, I've canceled those 8s, and now it's opened up to 15 plus x equals 8 times 3 is 24. And now I take care of adding and subtracting. So if I want to get rid of the 15, I'm going to subtract 15. So 24 minus 15, 14, 5 is 9 equals x. That's what x is. So let's take that into consideration. Let's do number 11. So yes, I see subtraction and I see division, and technically my mind wants me to add 8 first, but because of that dividing by 6 kind of overpowers it, we're going to multiply by 6 first to both sides so that those 6's cancel, and I have x minus 8 equals -2 times 6 is -12. And now that I see subtraction, I'm going to do the inverse, which means I'm going to add 8 to both sides, where those 8's cancel, and x equals -12 plus 8 is -4. Let's do one more of those. So again, I see subtraction, I see division, and SADMAP tells me to take care of subtraction first. But this dividing by 2 is in the way. So I'm going to multiply by 2 to both sides. So 2 times -4 is -8. These 2's cancel, so it's opened up the x minus 3 by itself. So the inverse of subtracting 3 is to add 3 to both sides. So -8 plus 3 is -5 equals x, because those 3's cancel. So these are just the 3 exceptions to the SADMAP rule. But other than those, you follow SADMAP. So